Hello, the purpose of the following video is to show you how to get the measures of central tendency and variability in Excel. Now, just like all the other videos, make sure you have your Excel spreadsheet open and directions in the Word document available so you can follow along and replicate what I do. As always, you're welcome to pause the video at any time to either catch up or to look at your notes. Now, the first step we always do when we open a spreadsheet is to check the codebook and make sure that we understand how the variable was collected and how it is being measured. So in this particular case, we see we have a variable here labeled coffee. If I hover over the label, I see that the note in there says it's dollars spent on coffee. We'll just check our codebook just really quick to see the actual question that was asked of our participants. And it looks like it's on average, how much do you spend on coffee per week? So in a week, how much money do you spend on coffee? Now we'll go back to our data here. And remember, the second thing that we need to do is to sort our data to push any empty cells or blank cells to the bottom of the spreadsheet. At this point, you should know how to do this, but we'll just highlight the column, click our sort and filter, and then sort smallest to largest. Now, of course, we're always going to expand the selection just to make sure that our rows integrity is the same. And we're just going to scroll down and just see if we had any empty cells there. It looks like we had one. That very last cell seemed to be an empty cell or some missing data. So one participant didn't want to tell us how much they spend in coffee in a week. All right, now that we have our data sorted, the next thing that we need to do is we need to make sure that we have the data analysis tool pack installed on our spreadsheet. And so there are separate directions for this. In the lecture, you can click on the lecture. It'll walk you through how to make sure that the data analysis tool pack is installed on your version of Excel. But we're just going to check really quick, and I'll just show you really quick on a PC how to do it. So we're going to find that tool pack under the data tab. Up here in the ribbon, we can go to the far right, and you'll see that mine is already installed. It says data analysis right here. So it's an add-on that you can get in Excel. I'm all set here, but I'm going to show you how to get it in case yours is not already set up with that data analysis tool pack already available. So what we're going to do is we're going to go to our File tab. We'll go down to the bottom here on the left-hand side, down to Options. And under Options, you're going to see on the left-hand side an icon for add-ins. So we're going to click the add-ins. And then you'll see here in the add-ins, you'll see two add-ins. There's a tool pack and a tool pack VBA. We can just click on the analysis tool pack and then go to Go. And you'll see here it gives us a couple options. We just want to check those two boxes, click OK. And if we didn't have the data analysis tool pack, it would now show up here in the ribbon under the data tab. But we're all set up here, so we can go ahead and continue on to our directions. So if you haven't already, go ahead and download those directions for Excel for getting your measures of central tendency and variability. You'll notice here that it'll walk you through the steps. So we're going to click on our data tab. We'll click on data analysis, click on descriptive statistics, check OK, input our data range, make sure we check the labels in the first row box if we're selecting the labels in our data range, indicate where we want to put the data, and then make sure we check the summary statistics box, and then we'll click OK. And that will give us our descriptive statistics, our measures of central tendency, and measures of variability. So let's go ahead and do that. So again, I'm already on the data tab. We'll go to our data analysis tool pack. You'll see here on the left-hand side, you'll see an option for descriptive statistics. We're going to go ahead and highlight that. We'll click OK. From there, we need to indicate our data. And so we're just going to click on column B here. Just highlight the whole column. We do have labels in that very first row. It's being highlighted there, so we're going to check that box. I want to make sure I get my summary statistics because that's what's going to give me my measures of variability and my measures of central tendency. And then we want to indicate where we want to put the data. Now, later in the semester, we'll learn how to do transforms. So it's always a good habit to put your data at least a couple of columns, put your table at least a couple of columns away from your data. So I'll click in the box, and I'm just going to put it here in column G. And I'm going to click OK. And there's our descriptive statistics. you'll see here that we have our mean. I'll go ahead and highlight these. The mean, the median, and mode. So those are measures of central tendency. We have our measures of variability with the standard deviation. Use a different color there. The variance, and then the range. Now, one thing that you will notice here is that you'll see this say sample variance. And so Excel automatically thinks that you are sampling data, just because that's the most common thing that we do in statistics. Rarely do we actually measure the entire population. So what we get here is the sample variance and the sample standard deviation. So even though the standard deviation is the say sample, it is the sample standard deviation. If we did have population data, so let's just assume that everyone that we measured here is all we cared about, we weren't trying to infer to a larger group or a different group, then we would have population data. And so the formula for the standard deviation and population data, and also the variance, is slightly different. There's a difference in the denominator. So instead of dividing by n-1, you're dividing by n for the population. And so we don't have that particularly in the descriptive statistics box that's currently showing. So we'd have to calculate that separately. If you go down to your directions, you'll see that there are some notes on that. So here, note right here, the standard deviation variance provided is for sample data. To get a population standard deviation variance, we need to find an empty cell, and we need to type in a couple of commands to get those data. So let's start with getting the standard deviation for a population. So I'm just going to go to the side here. So we'll put it just right here, a couple columns away. And I'm going to hit equals. And we'll type in ST for standard, DEV for deviation, and then P for population. I'll do my open parentheses. Then notice here, what I want to make sure I do is I select the entire data that I had from the beginning. And so sometimes I'll see students just click on the standard deviation value in the table. That would be incorrect. Make sure you go back to the original data, right? And we'll close out that parentheses and we'll hit enter. And you're going to notice that the standard deviation, in this case for the population, is just slightly smaller than the sample estimate. Again, and that's because of that denominator being changed from n-1 to n. Right? So it becomes a little bit larger, which then makes the standard deviation just a little bit smaller. Same thing for variance. Again, if you're looking at the step-by-step directions, we'll hit equals VAR for variance, then P for population. Open parentheses, and then again, select the original data, right? Don't select in the table, don't select the variance, sample variance in the table, but the original data. Close out your parentheses and hit enter. And again, you'll notice that variance is just slightly less for the population than it was for our sample estimate for the population. Now, the next thing that we want to do is we want to go ahead and check our skewness statistic. So again, in this class, most of the statistical tests that we learn this semester will be based on and assume the normal distribution. And so we want to make sure that our data can be assumed to be normally distributed. And so in your output here, you're going to see that there is a skewness statistic. And so we're going to use this skewness statistic to determine whether or not we can make the assumption that these data are normally distributed, or if they're skewed distribution, right? It could be a positive skew or a negative skew. I can already see this number is quite large, so this is going to be a positive skew distribution, but I'll walk you through how you can tell. So in this case, our skewness value is 1.93. I'm going to scroll down in my directions here. So note here, we're going to check that skewness statistic of the variable, and we're going to get that from the descriptive statistics box, which we just highlighted. And then we're going to compare it to this skewness table. So the skewness table gives us the ranges of what would be considered acceptable for a normal distribution. Now, no set of data is going to give us a perfectly normal distribution. So we have a range of values that's centered around 0, because remember, if the mean and the median are the same, right, we're calculating our skewness statistic, the mean and the median fall right in the center of the distribution, that would indicate a normal distribution. But no set of data is perfect, and it's always going to deviate, even if just a little bit, when it comes to that skewness statistic. And so we want to know just how far is too far, and this table tells us what those values are. So we need to know a couple things for this skewness table. We need to know the number of observations. So you've learned that in the lectures to be the symbol n, so total number of observations. And once I know that, I can then use it to get the lower and the upper bound of what would be acceptable range for the skewness statistic to make the assumption that we have a normal distribution. Again, if you're looking at all these lower and upper values, you'll see that they're all centered at 0, right? So when the mean and median are the same, we would get a skewness statistic of 0, and that would indicate a perfectly normal distribution. All right, so let's take a look. Let's get our number of observations here. And we could go over and highlight our values and get a number, or we can just go down here to the count. And we see that there is 100 observations in this data set, or 100 values in this particular data set. So if I go down to my table and look for my n column, I'm going to go to n is 100. Notice that this very last one is going to be 100 and more, right? And that's going to give us these two values here. So negative and positive 0.37. And so those are going to be our ranges or our cutoffs for determining what is a normal distribution. If our skewness statistic falls between negative 0.37 and positive 0.37, then we'll say we have a normal distribution. But if our skewness statistic falls outside of that range, then we'll say it's a skewed distribution. If that skewness statistic is a positive value and it falls outside the range, we'll say it's a positively skewed distribution. If that skewness statistic is a negative value and falls outside this range, then we'll say it's a negatively skewed distribution. So in our case here, we have a skewness statistic of 1.93. 1.93 falls outside of our range in the positive direction, so positive 1.93. So that would indicate that we here have a positively skewed distribution. So it's not a normal distribution, it's a positively skewed distribution, which means that if we were to continue with these data to do one of our statistical tests or procedures that assume a normal distribution, then we would need to transform the data first, right, and try to normalize the data. And you learned in the lecture that if you have a positive skew, the best way to transform that data is to take all the original values and take those original values to an exponent less than 1. So typically we start with like a square root, but we could need something more powerful, especially when we see a large skewness statistic, a exponent lower than 0.5 or a square root may be necessary to transform the data and make it more normal. Okay, and there's just one more reminder here just at the bottom of the direction sheet. This is just to remind you that the skewness statistic is just one indicator of normality. We've learned about 3 in the class. We learned about looking at the graph, learned at looking at the measures of central tendency, the mean and the median in particular. Then we learned about the skewness statistic. So we have 3 indicators of normality. Sometimes those 3 indicators don't all agree with each other. And when that happens, usually we'll give more weight to the skewness statistic because it's a more objective measure. Looking at a graph is fairly subjective, as well as comparing a mean to a median and knowing just how far is too far off to assume a normal distribution or assume a skewed distribution. And so just remember that when we, in practice as researchers, try to determine the normality of a variable, we're looking at all the indicators and trying to make an informed decision based on the evidence that is provided. Well, that does it for the measures of central tendency and variability. Don't forget to fill out your spreadsheet as you were following along and make sure you upload that to the lecture assignment. Thank you.